All right, today we have topic 4.4, more parallel lines and algebra. And in this lesson, we will be continuing what we learned in topic 4.3, where we identify types of angle pairs with a couple of given angles. Then we will also be able to take that information, determine whether they're congruent, supplementary. Once we find that out, put the information that they give us, the algebraic terms, we'll put those in for the measures of angles, and then we'll be able to solve and determine the degrees of those angles. So let's go ahead and get started with our notes. Here we have the topic 4.4, more parallel lines in algebra. It gives us example 1. In example 1, it says if measure of angle 1 equals 7x minus 3. So I'm going to go over here to my angle 1, and I'm going to write down 7x minus 3. And the measure of angle 5, 8x minus 19. 8x minus 19. Find the value of x, and then we're going to find the measure of angle 4. So it gives us 1 and 5. Let's look at what types of angle pairs we have. Here are our two lines running parallel, and this would be our transversal. These would both be exterior. If we would take this, let me draw my interior. This would be my interior. So if this is my interior, both of these angles are exterior and they're alternate sides. If we know that, then we know that they are congruent. When they are congruent, what do? We set them equal to one another. So I've got a 7x minus 3 equals 8x minus 19. All right, so we're going to look to get our x on one side of the equation, seeing what we have here. I'm going to move my x to the right, because when doing so, we're just going to be left with a single x. And then I'm going to move my 19 by adding 19 to both sides. You do this, these will be removed. Negative 3 and a positive 19. Well, that would give you a 16. We have our equal sign. Positive 8, negative 7 will leave you the 1. So our x equals 16. We can come over here and we can put a box around that. It is solved. X equals 16. Now it's asking us for the measure of angle 4. So we want to know what the measure of this is. We know our x is 16. We know that, let's look at, we're going to be able to know the measure of our angle 5. So I'm going to go ahead and I'm going to find out what my measure of angle 5 is. We've got an 8 times a 16 minus 19. All right. So the measure of angle 5 is going to give you 8 times 16 minus 19. We're going to be looking at a 109, I believe. Ooh, delete that there. A 109. So the measure of this angle is 109 degrees. Angles 4 and 5, we know that they are a linear pair, and by definition, when you add them together, you get 180. So you have what we're after. We're going to go ahead and let's say that's an x at this point. We don't know. We're going to put in any variable. X plus our 109 equals 180. Subtract 109 from both sides. We'll eliminate here. That will leave you with our x, which is our measure of angle 4, equals 71. A 71. So let's go over here and let's put in the information we know. Our x equals 16. The measure of angle 4, we determined it right here. It is 71, and don't forget degrees. All right, let's look at example 2. We have if the measure of angle 4 equals 20x plus 3. Well, I'm going to take that. I'm going to find my 4 right here, and that is a 20x plus 3. Measure of angle 6 right here is a 9x plus 3. It wants us to find the value of x and then the measure of angle 3. It wants us to find this later on. But right now, information given. We have an angle pair. Here is our two parallel lines. So they're parallel. We've noticed that. Here's our transversal. That makes this our interior. So both of these are interior and both of them are on the same side. Same side interior angles. Go back to your previous notes. How do we find those? Same side interiors, you add the two together and they will equal 180. They are supplementary angles. So you add the two together. You have your 20x plus 3. And then you add your 9x plus 3. And they equal 180 degrees. You will end up with a 29x plus 6 equals 180. Let's get our 6 removed from that side. It'll leave you a 29. And then x equals 174. All right. Divide by 29. That's going to remove the 29. Divide by 29. You'll be left with x equals, and doing some quick math here, we will have 6. X equals 6. So we have found what our x equals. At this point, let's come over here. We're going to put in, we've got our angle 3. We can look at this two different ways. We can look at 3 and 4, because we'll know what 4 is going to equal. Or we can look at 3 and 6. For this example, let's look at 3 and 6. 3 and 6, they're alternate interior. Anything that's alternate, they're going to be congruent. So we can say that we know the measure of angle 3 will equal the measure of angle 6. We can say this. Angle 6 measure, let's solve for it. And that way we'll have the measure of angle 3. Angle 6, we can write down over here as our 9x plus 3. So it's a 9 times a 6 plus 3. 9 times 6. 54 plus 3. Final answer, it equals, measure of angle 3 is going to equal 57. So now I can come over here and I can put my final answers now that I have found my measure of angle 3. X we determined equals 6. And the measure of angle 3 equals a 57. 57. Alright, so let's move on to our second page of our notes. And here we have example 3. Example 3, it says if the measure of angle 3 equals 8x plus 3. So I'm going to come over here, I'm going to find my angle 3. I'm going to put in 8x plus 3. And the measure of angle 4 equals 20y minus 3. So 20y minus 3. And the measure of angle 7. Measure of angle 7 equals 11x minus 12. So 11x minus 12. Find the values of x and y. Now, when we look at this, there's a lot of information that is not needed. We can imagine right here, these lines can continue on for the sake of finding a transversal, but a lot of this is unnecessary. We don't need this line. We don't need to know anything about it. We don't need this line nor these angles in this example, in this question. Now that we've determined we don't need that, we have our two lines that are parallel, determined right here by our arrows within them. So two lines that are parallel, and this would be our transversal. So I have my interior right here. So now that we know this, we can simplify the equation, or the question. We'll make it to where it's not quite as much information that we need to look at. And now we can look at in solving for the values of x and y. We have angles 3 and 4 right here, which we know are a linear pair. Now, we know about a linear pair is they will add up to 180. However, we have a variable x and a variable y, neither of which we know what the actual value is. But with these variables, when we add them together, we will still have an x and a y in our equation, and we will not be able to solve for either one. The thing I would tell you to do with working these type problems would be find two angles that have a similar variable, in which this case 3 and 7, they both have the variable of x. So we can use this information to solve for our x, and once we solve for one variable, we can plug that in and then solve for the other variable. So first thing that we're going to want to do is we're going to solve for x, because we have two algebraic expressions with an x variable in that. Angles 3 and 7, they are interior and they are not on the same side, so they're alternate interior. We know that alternate interiors are congruent. So I can set my angle 3, which is 8x plus 3, equal to my 11x minus 12. Now, I'm going to go ahead and let's move over. I'm going to move my 12 to this side. Move my 8 to this side. 8s and the 12s will cancel out. We'll be left with a 15 equals, and doing our math, 11 minus 8 will give you a 3x. Divide both sides by 3. We will get an x is going to equal 5. So, there's one of my answers. X equals 5. I want to come over here and I'm going to put that in. X equals 5. Now that we know that information, we can turn around and we can take this 5 and we can plug it in to either equation. Actually, we could plug it into 3 or 7, whichever one would be easiest for us to work with, because they're both going to be the same. And 4, let's look at 4 and 7. The type of angle pair there will be, they're both interior and they're the same side. Same side interior adds up to 180. They're supplementary as long as these lines are parallel. Now, 3 and 4, they are a linear pair, and then by definition, a linear pair is also supplementary. They add up to 180. So it really doesn't matter which one we choose. I'm going to look at 3 and 4 for the simple fact of we can tell that they're a linear pair. That should be very quick for you to determine that they're both on the same line. So an 8, well, we know our x, that's a 5 plus 3. Now we know that when we add these two together, so plus 20y minus 3, that they equal 180. So now we have to do some simple math. We're going to go ahead and we can eliminate our 3's right here. And we can say we have a 40. 8 times 5 is 40. plus 20y equals 180. Well, let's move our 40 over. That will eliminate the 40 there. That will leave you with a 20y equals 140. Divide both sides by 20. A quick way of doing that is, since you have two zeros, you can remove that. So 14 divided by 2, y equals 7. So, let me remove that and put my color. We have found that y equals 7. And you can use that if they wanted to know what the degrees were. You could turn around and you could put 7 into a y, 5 into an x, solve, and we could determine almost any of these angles that you see here. All right, so let's move down to our example 4. I'm going to start out, I'm going to put in any information that I know. So the measure of angle 2 equals 6y plus 5. 6y plus 5. Measure of angle 3 is 5x minus 16. 5x minus 16. The measure of angle 4 is 97 degrees. It's going to go ahead and give us this, 97 degrees. Measure of angle 5, 12z minus 1. 12z minus 1. So now we have a third variable. And the measure of angle 6 it gives us is 3x. 3x degrees. So find the values of x, y, and z. From what I said before, we're going to look for two equations, two angles that are dealing with the same variable, 3 and 6. So if we're going to deal with 3 and 6, we're going to look, here's going to be our transversal. These will be our two lines. Our two lines will extend right here. This will be one that's going on. Transversal coming up and through. Transversal coming down. With a line extending as such. That will make this my interior. I'm not going to draw over this so that way not to clutter the image. But these will be interior, and they are not on the same side, so they are alternate interior angles. We know that these, and that would include all of this right here, but with these other parallel lines also cutting it, these angles will be congruent. We will be able to determine that 3 and 6, they will be congruent because these are parallel. Now, if these lines out here were not parallel, one went off in this direction, one went off just straight up, you could not determine these are parallel. But since we have another set of parallel lines, we can state that 3 and 6 will be congruent. So, 3 and 6 are congruent. We know they they equal each other, they equal each other. So I can say a 5x minus 16 equals 3x. Subtract 5x. Negative 16 equals negative 2x. Divide both sides by negative 2. You'll be left with an x equals 8. X equals 8. So we have determined that our x is equal to an 8. So we know that x equals 8. I'm going to come over here and I'm going to fill in information we know. If x equals 8, then what is a 3 times an 8? Well, 3 times 8, that will give you our 24. So we'll be able to say this is 24 degrees. All right. And we know these two are congruent. So this is also a 24 degrees. Now, let's look at what we can do to solve here. We have a shape that is being formed by these two parallel sets of parallel lines in this transversal. We have here a triangle. All of the interior angles of a triangle add up to 180. We know two measures. Anytime you know two measures, that's whenever you're going to want to use this step in order to solve for another one. So we know that we have a 97 degrees, which we don't need the degrees to solve this. We have 97 plus 24. Those are these two angles, 3 and 4. Now our angle 5 plus a 12z minus 1. We know that all that, the interior angles of a triangle, equal 180. So, since we do know this, let's look at adding this up. We've got, that will be a 96 plus a 24 and 120 plus 12z is equal to 180. All right, so now we can subtract 120, subtract 120. 12z equals 60. Divide both sides by 12. Z equals 5. So there's one of our answers. Z is equal to a 5. All right, so if Z equals 5, then I know the answer to the measure of this angle, which is 12. Go ahead and grab another color here. We can say this is a 12 times a 5 minus a 1. 60 minus 1, so the measure of this angle is 59 degrees. So now we're looking at our y. We have to determine our y. And what can we say about a y? Well, we know that 3 and 6, they are alternate interiors, so they are congruent. So what about 2 and 5? 2 and 5 will also be our alternate interior. They will be on the opposite side, so they will be congruent. So in order to solve for y, you can have a 6y plus 5 equals 59. Subtract 5, subtract 5. 6y equals 54. Divide by 6. Y then equals 9. Let me grab the correct color over here. Y equals 9. So, stepping through that, determining what you know, and then being able to plug that in. As soon as you find a variable, then you should be able to solve for another variable. Take the two angles that have the same variable. In this case, were angle 3 and 6. We determined alternate interiors. So we determined we could set those equal to each other. They both had the x as a variable. We were able to solve for x. At that point, you can fill in more information that we know. You can take that information and keep running with that to determine and solve for your other variables in your other angles.